All right, so I've had a lot of questions about circuit number 2 on this lab. It is a little bit different. It's actually very similar to the one before it, but the branches look a little funny. So I'm going to go ahead and walk you through a few ways that you can do this and how I would recommend doing it. So first of all, if you look at the actual conventional current, which is the red arrows, if you turn on those red arrows, the conventional current, you can actually see those current results pretty nicely, all right, as opposed to using the electron model. So we can see here, if I use this junction here, we've got one current coming out of that junction, we've got one coming in here, and then this one coming in there. I'm going to go ahead and label them based on the resistances, just to keep it clear. So I've got I3 here that's going through resistor 3, I2 here that's going through resistor 2, and I1 that's going through resistor 1. Okay, so now we need to make our loops. All right, so the first and obvious one is going from V1 here, the 120 volt battery, and just following it around. Okay, the second one that we have traditionally been doing, sorry, I can't pick a color. I don't want red. That we've been traditionally doing is this one here. Okay, now if you do that, you need to notice that not only are we going through R2 backwards, but we're going through V1 backwards. All right, and so instead of subtracting this, you need to add it. Instead of adding this, you need to subtract it. Okay, now here's my recommendation. I'm always about working more efficiently and less work to it, or less subjectivity to it. So remember, we always have 3 possibilities. And so in this case, I would actually go all the way around and do this outside loop here. Okay, because then I don't have to worry about this extra battery and going backwards, that my loop that I drew is the opposite direction of that particular branch. Okay, because you could have also drawn it this way to go with this branch, but then you're going to be opposite the other way. So it gets a little complicated. It's very possible, don't get me wrong, you can absolutely do that. But in this case, for my V2, I've got my V2, and then it's going through minus my I3, R3, and then it is bypassing, as we're going through here, it is bypassing that whole middle branch and keeping going around, and then we're in the same direction of my what do we call that? 1R1, and then as we keep going, we don't even hit anything the whole way back, so that's going to equal 0. Okay, so that's a much simpler setup than trying to do this inside loop. But again, if you're up for the challenge, it is absolutely possible. All right, and so when you do check your work by building this, you should get the correct answers, or very similar, just like you did in circuit 1. But I know a few of you I've had quite a few emails about this circuit too, so I thought I'd help you guys out with how to draw these loops. All right, so if you're good, go ahead and keep working on that. I'm just going to go ahead and do this purple, this loop 1 that I originally did here. So where we have our V1, okay, it's going up this way, minus our I2, R2. Whoa, that's not a 2. There we go. Minus I1, R1 is equal to 0. Okay, and I missed this little 1 here. All right, so there's your 2 voltage, and then kind of really poorly drawn in, I don't know what color here, but your I1, I3, and I2. And again, that's going to be I2 is equal to, sorry, now I'm messing up. I1 is equal to I2 plus I3. Okay, try to always do them in addition, so that you're always going to have either 2 going in or 2 coming out. Those 2 are added to equal the one that's going in the opposite direction. Okay, I hope that helps.